Financial Modeling, Topic 8, Section 5. Understanding the at-risk simulation personal financial model. So in this topic, we're going to use the same exact model that we've developed over the last 4 topics in this section, or last 4 sections in this topic, except I'm going to convert it to an at-risk model. And how I'm going to do that, I'm going to go to my model. I'm going to take my exact formula I have for my macro simulation that says my portfolio grows by the mean plus a random variable. In Excel, that's the standard normal random variable estimated by the formula norm S inverse rand times the volatility. I'm just going to replace this norm S inverse rand with risk normal 0, 1, which is an at-risk statement or code to say this is an area to generate standard or random numbers when running a simulation. Now notice I have at risk, I've run at risk, so notice I now have the at-risk add-in all loaded. I have these at-risk normal 0, 1s filled in right here. So these take the place of the norm S inverse rands, and then I just specify some outputs. In other words, what are the things I want to collect data on? And notice I have my count number of years I'm solvent. I clicked on that cell and hit add output. I'm also collecting data on my shortfall. I'm also collecting data on my portfolio value. So I have a risk output here and so on. I also collect data on my age of death by putting risk output in front of this. So now I'm just going to go to at risk. I'm not going to run this because it sometimes takes a couple minutes. I'm going to do 10,000 iterations, hit start simulation. And when that's done, the at risk will then calculate statistics. Give me the 5% lowest of that portfolio value, the 5% highest of that portfolio value. Notice it's almost giving me the same value as my macro, and it should. And if I ran, say, 100,000 at the at risk, and 100,000 for my macro, these would converge to the same values. I also calculate the risk target, 0. Tell me the percent of time this number is less than 0. Just like I did with this one, where I counted the number of times that number is less than 0. I also get the same value. So the risk target tells me the probability that some number is less than, some number 0 in this case is less than there. So I haven't really gained anything with at risk. However, it is a lot easier to run this. I don't have to worry about collecting this data, and usually runs faster. Now the real advantage of at risk is I can take any of my outputs, say year of death. I can browse my results, and now I could see the full distribution of my lifespan, assuming normal distributions. I can see, say, there's my 90% confidence interval. I'm 90% confident I'll live between 73.5 and 96.5 years. Or I can figure out what's the probability of me living to 100. And I can say, okay, there's a 1.6% chance of me living to 100 based on normal distributions. I can then look at my portfolio value and browse results. And notice that the mean, again, is about $2.7 million. That's just like the static value and the macro simulation. But now you can see there's scenarios here where it looks like I have $15 million. And there's scenarios here where it looks like I have less than $500,000. And then here's the full distribution of my portfolio values. I can then look at my, say, shortfall years. Well, let's look at portfolio death. At what age did my portfolio die? And what you see is some years it let the portfolio last up to 160 years, and then some much less, with the mean of 109 or 110 years. And then the last one is the number of years the portfolio lived. Whoop, wrong one. I have it out here. Number of years in which I ran out of money. I'm going to browse results. Notice on average, the mean is I have an extra 25 years of money. However, what you can see here, 75% of the time, I have plenty of money. I have negative unfunded years, 25% of the time I have a shortfall. And I could play with this distribution and say, what is the 10%? I'm sorry, put 90% confidence interval in here, and see I'm 90% confident I'll have between 12 years and negative 92 years of shortfalls. So that's the advantage of at risk. Besides just the easiness of kind of just typing in that risk normal 0, 1 and looking at the outputs, it also can let me explore the distribution.